Hello, hi everyone, and welcome to this live for Crack Maths. Today we are looking at probability. Okay, so what I'm going to do is, one second, here we go, just undo that. What I'm going to do is I'm going to be going through some past paper exam questions all about probability, and we will take it from here. So let's have a look over at this first question. Sorry, one second, just organising a few bits and bobs. So here we go. Great, I've got my chat going. If anyone wants to ask any questions, by the way, feel free. Yeah, otherwise I'm just gonna begin. So here we go. What I've got here is it's got this first question. And it says here, Zach wants to find out how accurate the weather forecast is. Sorry, I'm just going to try and enlarge this a little bit so I can see what's going on. Okay, so what we've got here says, Zach wants to find out how accurate the weather forecast is. The table shows the last 6 months forecast for rain. It also shows the number of days that it actually rained or stayed dry. So here we go, we can see we've got the two-way table. And then, so I just want to check the table shows, yeah. So we've got the two-way table here, and I can see that it says actual weather at the top, and it says rain and dry there, and then it says forecast. Right, so what I need to do is, I need to make some sense of what is going on in this table. So let me just, sorry, 1 second. Okay, so what we can see is we've got at the side, it says forecast, okay, and at the top it says actual weather. The question was the forecast more likely to be right when it was rain or when it was dry weather? Explain how you decide. Right, so if I look at the forecast for rain, I can read across this line here. This is the forecast for rain. So I can see that it was forecast to rain 70 times and 60 times. So all in total, there was 130 days that rain was forecast. Now, out of those days, I can see that 70 of those, I can see that out of those days, 70 of those, it did rain, okay? So 70 out of 130 days, it was correct. So that's the probability there that the forecast was correct for rain. 70 out of 130. Now what I can see is we've got here the forecast for dry days. So the forecast for dry days shows that there was 36 days that were forecast when it rained, 16 when it was dry. So there's 36 plus 16, let's work that out. 36 plus 16 is going to be, 36 plus 16 is going to be 52 days that it was forecast to be dry. Now, out of those, how many were dry? Well, I can see that there was 16 days of the forecast that were dry. This is a confusing question, really. It's a lot to get your head around. So there's 16 out of 52 days. That's a 56. That's a 15. Oh dear. There was 16 out of 52 days that were forecast to be dry that were dry. So now what I need to know is which number is bigger. Is 7 out of 130 more likely? Or is 16 out of 52 more likely? So what I need to do is I need to simplify these fractions until they are both of the same sort so that I can actually compare them. So I can see here 70 over 30, 70 over 130 can simplify to 7 over 13. Okay, great. Now, let's have a look at this one here, 16 over 52. Well, I can see that they're both even numbers. So what I can do is I can half both of those, and that will become 8 over 26. Okay, I can half both of those again, and that equals 4 out of 13. Right, that's very useful because now our fractions are in the same form. So we can see that the forecast for rain was likely to be correct 7 out of 13 times, and the forecast for dry was likely to be correct 4 out of 13 times. So as 7 out of 13 is more than 4 out of 13, that means it's more likely to be forecast for rain correctly. Okay, so I'll put that there. So the answer is rain. Oh, let's get that. So the answer is going to be rain. Right. Okay, let's take a look at the next question. Right, so this question says that the probability that Hannah makes a profit when she sells any item at an auction is 0.8. What is the probability that neither of the next two items she sells online at auction make a profit? Okay, so if the probability, so this is actually like probability trees here. So basically, what I'm going to do is she either makes a profit or she doesn't. So I'm going to call it P or N. P for profit, N for naught. Then what we've got here is we've got P for profit, N for no profit, P for profit, N for no profit. So the way this works is I can put the probabilities on the branches. So the probability that she makes a profit is 0.8. Now probabilities always add up to 1. So that means that the probability that she doesn't make a profit is going to be 0.2. And then again, I can put that over here. So we've got 0.8, 0.2, 0.8, 0.2. So we want the probability that she doesn't make a profit at any time. Okay, so we're looking for this route. So we're looking for her not to make a profit on the first go, and then we're looking for her not to make a profit on the second go. So what that gives us is that going to give us 0.2 times 0.2. So the way that probability trees work, is that we just multiply along the branches. So if I wanted the probability of both events, I'd do 0.8 times 0.8. If I wanted this probability here, this one of probability yes, then no, I would do 0.8 times 0.2. If I wanted the probability that she didn't make the sale, then she did, I'd do 0.2 times 0.8. And then if I want the probability that she doesn't make the sale both times, I'm going to do 0.2 times 0.2. So 0.2 times 0.2. Right, now this is like doing 2 times 2, which is 4. And then I've got to divide it by 10 twice. So this becomes 0.04. Okay, so there we go. That is the probability that she doesn't make any profit with the next two items that she sells online. Okay, let's scroll up and have a look at this next question, question 3. Okay, so question 3 here says, the probability that a salesperson will get an order from a customer is 1 over 4. She has 2 visits tomorrow. What is the probability that she will get orders from both the visits? Okay, again, this is like our probability trees. So what I can do is I can think about it. She gets an order, order, no order, order, no order, order, no order. Okay, so the probability that she gets the order is 1 out of 4. Okay, so if the probability that she gets the order is 1 out of 4, the probability that she doesn't get the order is 3 out of 4, because when we're talking about probabilities with fractions, it's important that we know that the full fraction is certain. So if something either happens or it doesn't happen, they've got to complete the fraction. So 1 out of 4 plus 3 out of 4 does equal 4 out of 4, so that is the certainty. So then what we've got, if we've got 1 out of 4 here, we're going to have 1 out of 4 here, we'll have 3 out of 4 for the no order, 1 out of 4 here, 3 out of 4 here. So we want the probability that she gets orders from both, so that is this root here. So we're going to be looking at 1 out of 4 times 1 out of 4. Because remember, we multiply the probabilities along the branches. So 1 out of 4 times 1 out of 4, well 1 times 1 is 1, and 4 times 4 is 16. So the probability will be 1 out of 16. Okay, great. Let's have a look at the next question. Right, so here we go, we've got another question here, and this question says, a call centre aims to deal with calls in less than 5 minutes. Calls can come in randomly. The table shows data for the calls made to the centre. Okay, so here we go. We've got type of call, proportion of calls, completed in less than 5 minutes. Okay, work out the probability that the next call will be a customer complaint completed in under 5 minutes. Give your answer as a fraction in its simplest form. Right, okay, so first of all, we need to look at the proportion of calls that are complaints made in under 5 minutes. Well, first of all, let's look at the proportion of calls that are customer complaints. So here we go, we can see that a quarter of the calls are customer complaints, okay? So that's useful to know. So we know that we're looking at a quarter of the calls. We then know of these calls, half of them are completed in less than 5 minutes. So we are looking for a half of a quarter. So remember, of means times, so a half of a quarter is going to be 1 over 2 times 1 over 4, and that will equal 1 over 8, okay? So the probability of this is going to be 1 out of 8. Okay, great. Let's have a look at the next question. Let me scroll. Okay, here we go. We've got question 5. Okay, so question 5 says, if I look at this, it says, a commuter uses a bus and a train to get to work. The train is more than 5 minutes late 1/6 of the time. The bus is more than 5 minutes late 3/5 of the time. Okay, what is the probability that both the bus and the train will be more than 5 minutes late? Okay, so what I need to do is I need to think about this. So we've got the train is late 1/6 of the time, so we're going to do 1/6 because we're in 1/6 of the time here, and then we then want 3/5 of the time. The bus is late, so we want, if we're in the world where it's 1/6, we're going to want 1/6 times 3/5, and this will be 3 out of 30. And they haven't asked for its simplest form, so that is absolutely fine as an answer. Okay. So let's have a look at the next question. Okay, here we go. We've got question 6 here. And question 6 says, when Highfield Transport gets busy, it offers overtime to a driver. There are 5 drivers at the Highfield Transport Centre. 1 second, I'm just going to... Okay. Oh, what's happened? Right, so there's 5 people at the Highfield Transport Centre. The probability of there being overtime available in any given week is a quarter. The driver allocated overtime is chosen at random. What is the probability of you being allocated overtime next week? Give your answer as a fraction and a percentage. Okay, right. I need to read this question again. So it says here, when Highfield Transport gets busy, it offers overtime to a driver. There are 5 drivers at the Highfield Transport Centre. The probability of there being overtime available in any given week is 1/4. Okay, fine. So if you're a driver, there's 5 of you, so the probability of being picked is 1 out of 5. Okay? Now, the probability that there being overtime available in a given week is 1 out of 4. So basically, we're looking for both of these things to happen at once. So 1/4 of the time, there is overtime, and 1/5 of the time, you're the driver that's picked. So, of that, so we can also think, they want this in percentages as well, and that's useful to think about. So 25%, 1/4 is 25%. Okay, so 25% of the time, okay, they require overtime. And then 1/5 of the time, okay, which is 20%, 1/5 of the time, you're the driver that's selected. So basically what we're looking for is we're looking for 1/5 of 25%, okay, or 1/5 of 1/4, or 20% of 25%. Okay, so let's have a look here. Let's do the fraction bit first because that's easiest. So what I'm going to do is I'm going to do the 1 times the 1 and the 5 times the 5. So 1 times 1 is 1, 4 times 5 is 20. Okay, so the probability of being the driver that's chosen for the overtime is 1 out of 20. Okay, so now what we need to do is we need to convert this into a percentage. So remember that a percentage means a fraction out of 100. So let's see if we can convert this fraction to 100. So what I need to do is I need to think about, what do I multiply 20 by to get to 100? Okay, and I times them both by 5. Okay, so 1/20 is going to be 5 out of 100, which equals 5%. So here we go, our answers are 5% and 1/20. Okay, let's have a look at another question. So here we go, we've got question 7 here. And question 7 says, your friend Joanna volunteers at the kennels. There are 12 volunteers in total. Only 8 volunteers are needed per day, and they are chosen at random. The kennels are split into small dogs and large dogs. There are 25 small dogs and 11 large dogs. Volunteers who are working are allocated a dog at random to walk. Right, okay. On any given day, what is the probability of your friend Joanna working and being allocated a large dog? Right, okay, so first of all, let's draw this as a probability tree just to help us out. So we could have Joanna, or they could have no Joanna. There's 12 volunteers, so the probability of one of them being Joanna is 1 out of 12. Okay? The probability of it not being Joanna would be 11 out of 12. Then what we have, 1 second, I got this wrong. It's not 1 out of 12 for Joanna. They select 8 people. So Joanna has an 8 in 12 chance of being selected. She then has a 4 in 12 chance of not being selected. We then have 25 small dogs and 11 large dogs. So 25 plus 11 equals 36. Okay, so Joanna's chance of being given a large dog is going to be 11 out of 36. So the probability that Joanna is selected and allocated a large dog is this path here. So what we need to do is we need to do 8 over 12 multiplied by 11 out of 36. Okay? Give your answer as a fraction, that's fine, they haven't asked for the simplest form, so we can kind of do it like this, although actually these numbers are a little bit complicated. So what I'm going to do is I'm actually going to simplify this fraction first before I do this calculation. So 8 over 12 equals 4 over 6 equals 2 over 3. Okay, so what we're looking at really, we're doing the calculation of 2 over 3 multiplied by 11 over 36. Okay, well 2 times 11 is 22. 36 times 3, well we've got 6 times 3 is 18. 3 times 3 is 9 plus the 1 is 10. Okay, so this would be 108. And actually, if we wanted to simplify this, we could actually, so we could do 22 and 108 both divided by 2. So that will be 11 over 54. So there we go, that's our probability. Again, they didn't ask for the simplest form, they just asked for it to be in a fraction. So it's up to you what you do with that. But that is the answer to that question. Okay, here we go. We've got the next question here. And this question says, a box contains sweets that are either covered with dark chocolate or milk chocolate. There are twice as many sweets covered in dark chocolate than there are covered in milk chocolate. The sweets have different flavoured centres: strawberry, lemon and cherry. There are equal number of each flavour. The diagram shows options of picking each chocolate and the flavour. Okay, right, so we can fill out some bits of this. So we can see that if it's 1/3 for milk, that means on this other side here, it's going to be 2/3. Okay, so I'll put that down there. So we know that 2/3 are dark chocolate. Oh, right, this bit's a bit complicated. There are twice as many sweets covered. Oh, no, that bit's done. The sweets have different flavours: strawberry, lemon and cherry. There are an equal number of each flavour. Okay, that is better because that means there's 3 flavours, an equal number of each flavour. So what we can do is we can know that each of these is 1/3. So you've got 1/3 of a chance of getting each one. Okay, so what we've got here, complete the diagram with the probability for each branch. Use the diagram to find the probability of picking a strawberry flavour sweet with milk chocolate. Okay, right, so what we're gonna, Okay, so I'm guessing actually they wanted in these boxes, it's weird, they usually put the probability on the lines, but they've put boxes here. So, but according to the question, they want us to use the diagram to find the probability of picking a strawberry flavour sweet with milk chocolate. So, here we go, let's look through. So milk chocolate is this route, strawberry flavour here. So, if I'm going to do this, I've got the probability of getting a milk chocolate strawberry is going to be 1/3 times 1/3, which will equal 1/9. And there we go, that will be the answer. So I can put that answer here, and that is 1/9. Okay, great. Let's take a look at the next question. Right, so here we go. We've got question 9 here. And question 9 says, the frequency tree shows information about the colour of 44 items. One of the items is chosen at random. So we have here red and blue. Okay, right. So let's just see how this frequency tree works. So it's got 44 here, it's got 20 here, and it's got 24 here. So all I can presume from this is that there are 24 red items. Nope, got that wrong. 20 red items. And there are 24 blue items. And that makes sense because 20 add 24 is 44. Okay, so it says here, work out the probability that your item is blue. So that looks to me like it's going to be 24 out of 44. And they've said to give your answer in its simplest form. So what we can do is we can continue to just cancel these down. So 24 divided by 2 is 12. 44 divided by 2 is 22. We can go again because they're both even still. So that would be 6 out of 11. 11 is a prime number, so that can't be divided any further. So I am going to stop there. And that will be that. So our answer is 6 out of 11. Okay, let's see what's next. Okay, nothing there. Okay, right. Just as a little note, this is now a calculator question. So I can actually get my calculator out because I think that's probably going to be useful. So I'm just going to fill the screen there. I'm going to get my calculator. I can drag this over here. Right, so it's always useful to have. And then let's just go back here. Okay, so this question says, Dan throws 2 fair dice. The numbers on dice A are 1, -2, 3, -4, 5 and -6. The numbers on dice B are -1, 2, -3, 4, -5 and 6. The table shows some of the scores from throwing 2 dice. Complete the table. Right, okay, fine. So, let's just look at this table here. So to me it seems like we've got these numbers, okay? We've got these numbers here and they've been added together. So here, this is -3 because -2 add -1 equals -3. And I can show you that on the calculator actually. So I've got -2 plus, well, make that -2 plus -1. So make that negative as well. And that equals -3. Okay, so let's complete these. Well, some of them I'm going to complete with the calculator, some I can just see. So here, if I've got 5, this one is going to be 5 and -1. So 5 and -1, well, I can show you here actually. 5 add 1 and making it negative. This is actually just the same as 5 take away 1. So that is going to be 4. So I'll put a 4 here. Then what I have, I've got some more. I'm going to have 2 add -2. Well, 2 take away 2 is 0. Here what I've got is I've got 2 add -6. Okay, so let's look at what that is. 2 add 6, make it negative. That's -4. Okay, 3 add -3 is going to be 0. You'll notice that any number at its negative is going to be 0. We can see that down the middle. And then what we've got here, let's just continue to do the rest. So 1 add 6 is 7. Do the 5. Okay, so 5 take away 3 is 2. -3 plus -6. Okay, I'll do that on the calculator just to show you. So 3 negative plus 6 negative. This is actually going to be -9. Okay, so that's -9. 4 take away 6 is -2. 5 add 4 is 9. 5 add 6 is 11. -4 add -5 is -9. 3 add 4 is 7. minus 2 add minus 5 is minus 7, and 6 6 take away 2 is 4. Okay, so there we go, we've completed the table there. Let's see where the question is going next. So the next part of the question says, Dan throws 2 dice once. What is the probability that his score is negative 11? Okay, so let me get a different colour here and let me highlight all the negative 11s. Here we go. Done. Okay, there's only one negative 11. So what we can do now is we can write our probability. So it's going to be 1 out of however many options there were. So we had 1, 2, 3, 4, 5, 6 options on each row, and there's 6 rows of 6. So there's going to be 36 squares there. So we've got 36 options. So the probability that the score is negative 11 is 1 out of 36. Okay, right, let's look at this next part. Dan throws 2 dice again. What is the probability that the new total score is 0? So what I've got here, I'm going to look down these, and I've got all of these zeros here. Let's count them. 1, 2, 3, 4, 5, 6. So that's 6, and there's still 36 here. So his probability is 6 out of 36. Okay, right, so let's move on. Okay, here we go. We've got another question here. This question is all about two-way tables. Okay, so it says May has this information about 100 flowering plants in her shop. Okay, we've got size of flower, stem length, and then what we can see is we've got the size of flower is broken into small and large, the stem length is broken into short and long, and what we can see here is we've got these things going on, and it says she will take a plant at random from these plants. Work out the probability that this plant will have a large flower and a long stem. Okay, so we want a large flower and a long stem, so that's going to be these 29 plants here. So there's 100 plants in total, so the probability that she gets the large flower and long stem is going to be 29 out of 100. Okay, let's have a look at this next bit. May will take a random plant from the 72 plants that have a large flower. Okay, so she's only talking about these plants now. So she's going to pick a random plant out of the 72 plants that have a large flower. So basically we're just looking at this group. Work out the probability that this plant will have a short stem. Okay, so a short stem is going to be, we're going to have 43 of them have a short stem out of the 72. Okay, and that's that. Okay, great. Let's have a look at another question. If anyone has questions to ask or anything, by the way, feel free to write them in the chat. It'd be lovely to hear from you. Otherwise, I'm happy just going through, and I will continue doing that. Okay, so let's have a look at this next question. So this next question says, the tree diagram shows the probability of selecting a car owner by their age and the type of car they have. Complete the probability tree. Okay, so remember, with probability trees, the branches have to add up to 1. Okay, so if the probability that they're under 30 is 0.3, the probability that they're over 30 will be 0.7. Then if the probability that they have an electric car is 0.15, well, the probability that they don't have an electric car is going to be 1 take away 0.15. which will be 0.85. And yeah, that's the probability tree completed. Right, the next part of the question says, a person is chosen at random. Work out the probability that the person is under 30 and has an electric car. So let's mark out our path. So we're going this way, we're going here, and we're going here. So remember, we multiply along the branches of a probability tree. So what we're going to be doing is we're going to be doing 0.3 times 0.4. Okay, so 0.3 times 0.4 is equal to 0.12 or 0.12. There we go. Okay, great. Right, let's continue. So here we go, we've got another question here. And this question says, there are 10 volunteers in the community archaeology group. The probability that they are all attend on a Sunday is 0.35. The probability that they all attend, the probability that they all attend on a Sunday, the probability that they all attend on a Saturday is 0.35. The probability that they all attend on a Sunday is at 0.12. The site is open next weekend. Calculate the probability that all the volunteers will attend on both Saturday and Sunday next week. Right, okay, so again, this is like a probability tree again, sort of. Well, it is. We could put it down as a probability tree. So if we think about it, so we've got sat, attend, don't, then we've got Sunday, attend, don't. Okay, so we want the, I don't need to fill out the rest because we want this route here. We want the probability that they both attend, they all attend on Saturday and Sunday. Okay, so let me put in the probabilities. So we've got 0.35 here, 0.12 here. So we're looking at the calculation of 0.35 times 0.12. Okay, I can do that on my calculator. So here we go, 0.35 times 0.12. And that equals 0.042 chance. Oh, no, they want it as a percentage. Ah, that's the decimal. Right, 1 second, let me remove that. So that equals 0.42 there. Now remember, to convert a decimal into a percentage, we times that by 100. So if I times that by 100 here, that means that there's a 4.2% chance that they all come. Right, okay, I am going to leave that there for today. If you want any more support on probability, you should check out the Crack Maths website. There's loads of tutorials. I've put a link to the probability tutorials in the description. And other than that, I will hopefully see you on Monday. Catch you soon. Bye.